Okay, so in this lesson, we're going to solve quadratic equations by factoring. Now that you know how to factor, one of the things you can do with that information is to solve quadratic equations. Now, not all quadratic equations can be factored, but the ones in this lesson will be. But there's going to be a couple of future lessons where we're going to solve quadratic equations. The quadratic equations cannot be solved by factoring. We're going to have to use what's called the quadratic formula to do those. But in this particular case, we'll be able to do it by factoring. Okay, so let's just talk about a few things though about what are quadratic equations. All right, so let's talk about quadratic equations. All right, so here's the definition of a quadratic equation. All right, so a quadratic equation is an equation that can be written in this form. That can be written in the form ax squared plus bx plus c. Remember when we looked at the AC method, but it has to be 0 on this side. So it's written in this form, ax squared plus bx plus c equals 0. And you're told that a, b, and c are real numbers. So they could be decimals, they could be fractions, they can be integers, they can be whole numbers, and so forth. They can be rational numbers, irrational numbers. But you're told that a cannot equal 0. So it can be any real number. A, b, and c can be any real number, but a cannot be 0. B and c can be 0. You will look at problems where a and c are 0, but you will notice as you go through this that a is not 0. A was never going to be 0 here, because if a was 0, let's think about this. If a was 0, then that means 0 times x squared is 0, and you're left with bx plus c. But bx plus c equals 0 is a linear equation. What we're solving here is quadratic. So in order for this to be a quadratic equation, a cannot be 0, because we have to have dx squared in there. Okay? So that's the reason why a cannot be 0. So look at some examples, though, of quadratic equations. So examples of quadratic equations. All right, so here's some examples. X squared minus 9x minus 22 equals 0. 4x squared minus 28 equal negative 49. X times 2x minus 7 equals 4. So those are examples of quadratic equations. Now you see this last one? This is quadratic because remember we have to have an x squared. But if I if I distribute the x times x times 2x rather, is 2x squared. So see, this becomes 2x squared minus 7x equal 4. So that is quadratic. Okay, so these are examples of quadratic equations. Now, the standard form of a quadratic equation, is this, is ax squared plus bx plus c equals 0. That's the standard form of a quadratic equation. So if you look at our three examples, the only one of those that was in standard form was this one, because all the terms was on one side, the constant on the other side was 0. So the only one that was in standard form is this one. See, this is not in standard form because of that negative 49 on the other side, and this is not in standard form because of that 4, and also because this had parentheses in it. We had to distribute. So if I brought that 4 over here, then this if we're both are 4 over, then this would be in standard form. So over here, 2x squared minus 7x minus 4 equals 0. That is now in standard form. Okay, that's in standard form. So as we do these problems, you're going to notice that as we do these problems, we're going to want to put those in standard form. Okay? All right. Now, here's something else that's going to be important. When you're solving a quadratic equation by factoring, this idea is important. This concept. This is called the zero factor property. Zero factor property. So you're going to notice as we solve these quadratic equations by factoring, we're going to use the words zero factor property. Okay, so that says this. If A and B are real numbers, okay, real numbers. If A and B are real numbers, and if you're told that the product A and B is 0, so you're told that you have two factors whose product is 0, then what that means is this. That means that one of these factors has to be 0. In order for let's say two numbers, 4 times what is 0? Well, that other factor has to be 0. 7 times 0 is 0. 8 times 0 is 0. 0 times 6 is 0. 0 times 9 is 0. So if you have two factors whose product is 0, then either the first one is equal to 0 or the second one is equal to 0. Okay? So that's called the zero factor property. And you can see how we're going to use it in a little while. All right. So when you're factoring something that's in standard form, okay? So let's say we have an equation in standard form. What you want to do if you're going to use the zero factor property is you're going to factor the trinomial, or let me write the quadratic equation. Factor the quadratic equation. Okay, and you're going to get something just like this. Remember the two binomials? And it's going to be equal to 0. And then we would set each one of these, then set each factor equal to 0. Okay, so then I'm going to set each factor equal to 0. All right, so let's look at this example. So number 1, solve. And this time it's solve, it's not factor. This time it's solve. Solve each equation. Okay, so let's suppose we had this. Suppose we had x minus 3 times x plus 1 is equal to 0. X minus 3 times x plus 1 is equal to 0. Okay, now keep in mind this is quadratic, because if you FOIL this out, what's x times x? X times x is x squared. So you're going to have an x squared term. So this is quadratic. But I want you to notice, though, is that this quadratic equation has already been factored. It's already been factored. So once you have it factored, you see those two factors have a product that's 0. So then you're going to use a zero factor property. If you have two factors, two or more, you can have more than two factors. But if you have two factors here whose product is 0, then that means that one of these has to be 0. So what that means is this. Remember, I'm using by the zero factor property. By the zero factor property, okay, by the zero factor property, what that means is that, see these two factors? What that means is this. X minus 3 has to equal 0, or x plus 1 has to equal 0. So one of those factors has to be 0. And notice I went from a quadratic equation to two linear equations. I went from a quadratic equation to two linear equations, and you just solve each linear equation, and you have your answer. So x here has to equal 3, x here has to equal -1. So those are your solutions. The solutions are x equal 3, and the other one is x equal -1. Okay, those are your solutions. Okay, you can always check yourself. Watch. Let's make sure that 3 is correct. 3 minus 3 is 0. So that's 0. Let's check. I'm checking here. X minus 3, x plus 1 equals 0. So let's check 3. Check x equals 3. So wherever we see an x, you plug in 3. 3 minus 3 times 3 plus 1. Oops, that's a 1. And I want to see if that's going to equal 0. So I have a little question mark here. 3 minus 3 is 0. 3 plus 1 is 4. 0 times 4 is 0. So 3 works. If you check negative 1, check x equal negative 1. So I have x minus 3, x plus 1 equals 0. Wherever you see an x, you plug in negative 1. Negative 1 minus 3, negative 1 plus 1. So again, is that equal to 0? Yes, it is, because this is negative 4. This is 0. 4 times 0 is 0. Okay? So these are your solutions. So again, now this one is easy because it was already factored for you. So you had two factors whose product is 0. If you have two factors whose product is 0, then you're going to use the zero factor property. You're going to set each of those factors equal to 0. So x minus 3 equals 0, or x plus 1 equals 0, and then you solve each equation. So I went from a quadratic to 2 linear. Okay? All right, so let's look at another one. All right, suppose we had, suppose we had 2x plus 3 times 4x minus 5 equals 0. So 2x plus 3 times 4x minus 5 equal 0. Okay, so again, this is quadratic. This is quadratic. Always check yourself, because 2x times 4x is 8x squared. So at some point, if I were to FOIL this out, I would have an 8x squared. Now, you don't want to do that. You don't want to FOIL it out because whenever you're solving a quadratic equation, you want to end up with these two binomials. You want to end up with factors whose product gives you that quadratic equation. And so you don't want a 0. You do want a 0 here. So that's good because you're going to use the zero factor property. So remember, the zero factor property says this: if you have two or more factors, whose product is 0, then one of these has to be 0. So either 2x plus 3 equals 0, or 4x minus 5 equals 0. So remember, by the zero factor property. So that's how I went from here to here. I used a zero factor property. But notice I went from a quadratic equation to two linear equations. So remember, this is quadratic equation. This is a quadratic equation. And these are linear equations. And remember, to solve a linear equation, you bring all the variables to one side, constant to the other. So I'm going to get 2x equals a negative 3. So remember, 2x equals negative 3. I'm going to have to divide both sides by 2. 2 divided by 2 is 1. So I get x to be a negative 3 halves. So that's one of your solutions. Over here, adding 5 to both sides, and combining like terms, these are zeros. These are opposites, so they have to be 0. I get 4x equal 5. All right, so to get x by itself, I divide both sides by the coefficient. 4 divided by 4 is 1. 1 times x is x. So I get 5/4. So those are your two solutions. All right. And you could check yourself. I'm just going to check, let's say, one of them. So let's just check x equal negative 3 halves. All right, so if I check x equals negative 3 halves in the original problem, all right, so wherever we see an x, I'm plug in negative 3 halves. So I get, right here, I get 2 times a negative 3 halves plus 3 times 4 times a negative 3 halves minus 5. And I want to see, is that product going to be 0? So wherever I saw an x, I plugged in negative 3 halves. All right. So remember, these twos right here will divide out. You're left with a negative 3 here. Negative 3 plus 3 times. Here, 2 goes into 2 one time. 2 goes into 4 two times. 2 times negative 3 is a negative 6 minus 5. Again, is that equal to 0? Well, negative 3 plus 3 is 0. Negative 6 times a negative 5 is negative 11, but 0 times negative 11 is 0. All right, so negative 3 has check. And if you do the same thing with 5/4, you'll see that it works as well. Okay? All right, so again, here I could have gone directly to zero factor property because this quadratic equation was already factored. And so you just said each one equal to 0, and you're done. There's your answer. All right, now let's look at this one. Okay, suppose we had this. X times x plus 6 equals 0. X times x plus 6 equals 0. Okay, so it's still quadratic because if I distribute, now notice here, if I FOILed, I got a quadratic because these were two binomials. So that's why I used the word FOIL. Here, this is binomial, but this is a monomial. So I'm not going to use the distributive. I'm not going to use the FOIL method here. I'm going to just use the distributive property. X times x is x squared. So I know this is quadratic because x times x is x squared. But it's already in factored form because you have, look at this, you have two factors whose product is 0. So by the zero factor property, I can set both of these that I have underlined, so it helps if you underline this, I can set each one of these equal to 0. So again, notice I went from a quadratic equation to two linear. These are two linear equations. And all you have to do is solve for x. Well, in this equation, x is already by itself, so one of your solutions is 0. Here, to get x by itself, I subtract 6 from both sides, so your other solution is negative 6. So those are your two solutions, 0 and negative 6. Okay, now number 4. All right, suppose you had this. Suppose you had, let's see. All right, okay. So let's suppose you had x minus a half times x plus a third equals 0. Now, it's just the same as the others. It's just that these have fractions, but it's no big deal. It's still quadratic because x times x is x squared. So you set each factor equal to 0 because since that's a 0 here, you want to go ahead and set both of those equal 0 by the zero factor property. So x minus a half equals 0, or x plus a third has to equal 0. So here I get x to be 1/2. There's one of your solutions. Here I get x to be negative 1/3. There's the other solution. Okay. All right. Now here's well, we'll stop here. So the next example, what's going to happen? The next lesson, what's going to happen? We're going to start looking at, well, what if this is not a 0? Okay. What if this is not a 0? Because the zero factor property said that this had to be 0, so that's why it's called the zero factor property. So that had to be a 0 there. But what if it's not? So that's what we're going to talk about in the next lesson.